Here I'm going to present the functionality of our microcontroller and assignment board for Project 1. To start, I'm going to present the functionality of the, you could say default, or the main program that we were assigned, which was to create up-down, increment, and decrement counter, you could say, that would display the value and roll either over from 31 to 0 if we go over 31, and roll from 0 to 31 if we go under 0. So initially, we can see that the count is at 0 because no LEDs are on, and our increment switch is switch 1, our decrement switch is switch 2. So first I will start by incrementing all the way up over 31. And I'm actually going to switch the lighting scheme to the 2x4 and use the B LEDs at the beginning here because it's a little bit easier to see when you say counting in binary. And hopefully you can see this. So that's at 16, 17. And now we're at 31, so as part of the assignment, when we increment up going over 31, the speaker will sound we programmed ours to sound for approximately 4 seconds, and then it'll roll back over to 0. So there's the speaker, so we're now back at 0, and I'll increment up 1 or 2 times to show. So now we're at 1 again, 2, and now to show the decrement, we're at 2, go down to 1, go down to 0, and then if we decrement down once, it will go back up, we'll sound the speaker again, and then go back up to 31. And then now we can see we are at 31. We'll go back to 0 here. So for our own individual portions of the project, what we did is we each created our own individual function, and we assigned each function to one of the other push buttons. So for Nick Morton's function, he is showing each digit 0 through 9 as a 9-segment LED display, you could say. Because it doesn't naturally have a 7-segment LED, we decided to do ours in the 9 mode. I'm going to switch it from 2x4 to 3x3 so that's easier to see. So starting at 0, all we do for Nick Morton's function is we push switch 3, and we can see the output. Oh, whoops, forgot to switch. So that's 0. 1, as you can also see from the LED. So there's 1. This is 2. You can kind of see it. It goes like this, down. It's like, think about it as a Z. But if you use your imagination, you can see it well enough. So now we're at 3, and here's 3. Because of our delays, sometimes you have to we have to push it slightly later just to make sure we're working within our delays. Here's 4. There's 5, and you can see it goes like this, and then down and around. 6, we have here, and then like that. 7, you just go across and down. 8, which would be here, and then here. And then 9 for the final digit, which you can think about it like this. So that's Nick Morton's function. For Peter's function, we have a stopwatch that'll increment up and count in binary, and we'll push switch 4 to activate the stopwatch, and then when we want to stop the stopwatch, we will push switch 9, and whatever value the stopwatch stops at, it gets put into the up and down counter value. So we'll start the stopwatch here, and the stopwatch always starts from 0. So it's 0 for a second, we'll let this go up. One thing to note is that if we do decide to stop the stopwatch past the value of 31, so 32 and above, the increment up and down counter will hold that value unless we increment up or down, and then once we increment up or down, if it is exceeding that value in the range of no values, then it will activate the speaker and go back to 0 or 31, depending on if you incremented or decremented. So we'll kind of show it here. I'll go back to 2x4 since we're looking at a binary number. So now I believe we stop it, because this is 32. We can hold it. So the stopwatch is stopped. And then if we increment, it should sound the speaker and go back to 0 here. Just note, however, if we do stop the stopwatch, again, within the 0 to 31 range, there will be no speaker because it's in the range of the standard increment up-down counter. That's just how we decided to design our system. So that was Peter's function. For Matt's function, we can give the increment up and down counter any value that we choose by pushing the selected push buttons that we want. So what we do for Matt's function is, after I push switch 5, I'll hold whatever values or whatever push buttons I want corresponding to the binary value that we want to be stored in our increment up-down counter for 3 seconds, or until we see the LED display go on. Then it will display that value for another 3 seconds before we can actually do anything, just to, you could say, lock that value in. And same with Peter's function, we can give it any value in a 0 to 255 range. So if we do decide to give it a value over 31, upon an increment or decrement after, it will sound the alarm and go back to either 0 or 31. But if you give it a value within the range, there will be no problem with that. So I'll give it a value within the range. I'll give it a value of 7, just because it's easy with the 3 fingers. So push. So all 3, we wait another 3 seconds. And then now I should be able to increment and decrement again. So let's see. Increment up, there we go. 4, we have 9, decrement down, 8, 7 again. So for my function, or Nathan's function, which is switch 6, it'll be a 5 to 0 countdown timer with approximately a second in between. And it's same with Peter's. The delay in between you could say the stopwatch function was also 1 second. So it'll be a 5 through 0 countdown, and then once it reaches 0, it'll sound the alarm, and then for about 4 seconds, and then it'll go back to the normal function of the up and down counter from 0 to 31. So if I push switch 6, I'll display it in a 3x3. That's 2, that's 1, and then 0. We'll do that one more time. And then it also keeps the value of whatever was in the increment up and down counter before, but we'll do it again with the 3x3 instead. So 5, 4, 3, 2, 1, 0. And that is everything for our board.